Welcome to Ask and Learn.
We're told that in a tug-of-war, Sam and Maddy each pulls on the rope with a force of 250 newtons. And we want to figure out what the tension in the rope is. If both remain motionless, what horizontal force does each exert against the ground? We have our Sam, Maddy pulling on a rope against one another. Again, we're going to isolate them from their surroundings and the rope. So for Sam, we have a force from the rope. We have his weight acting down and normal force acting up from the ground, and also a force resisting his motion from the ground. For the rope, we have the force from Ken and the force from Maddy. These forces here have to be equal from Newton's third laws. Likewise, these have to be equal. So they're each pulling with 250 newtons. So then if we look at Maddy, there's the force from the rope, the weight, normal force from the ground, and then a force from the ground resisting the motion, the force from the rope. If we look at this, again, these have to be equal to one another if neither of these two are moving, because if the rope has no mass, then F1 has to be equal to F2, although that was given in the problem. So they must equal each other, so the tension in the rope is just 250 newtons. If neither is moving, so the acceleration in the horizontal direction of each person is 0, minus F1 minus F2 has to be 0, so that this force here must be 250 newtons. And likewise for Maddy, F2, actually this should be minus F2 plus F4, keep our sign convention correct. F2 minus F2 plus F4 has to be 0, so that F4 is equal to F2, and so F4 is also 250 newtons.